We're going to be looking at these 4 different types of ratio questions, but before we jump into that, let's have a quick recap on exactly what ratios are and how we can think about them.
So, what is ratio? Well, one of the best ways to think of ratio is as a comparison between two or more quantities or two or more amounts. So, an example might be for every 1 part of concentrate, we need 4 parts of water. And you'll often see ratios presented in this way, especially if you're new to ratios. So, this might look like one orange box. So, this might look like one orange box and 4 blue boxes to represent for every 1 part of concentrate, we need 4 parts of water to make a drink. And you can obviously see from here that in a glass there'd be 4 times as much water as there would be concentrate. And overall in this particular ratio, we have 5 parts in this ratio. But let's have a little go at how we might answer a question to do with working out what the ratio is for a group of objects. So here you can see a number of different pentagons. We have green and blue. And if we organize them, we can see if we can find out what ratio they are in. Let's see if we can look at these regular pentagons and work out what ratio the green shapes are in terms of the blue shapes. So if we organize these, we can see that for every 4 green shapes, we actually have 8 blue shapes. But we can simplify this a little bit. We could write it as 4 to 8, and that would be an okay way to express this ratio. But we could simplify this by thinking about it for every 2 green shapes, there's 4 blue shapes. And we just have 2 lots of that. And that gives us our 4 and 8 that we started with. But we can actually simplify another time. We could think about it as for every 1 green shape, there's 2 blue shapes. And we just have that relationship duplicated 4 times to give us our 4 and 8. So if we write this as ratios, we have 4 to 8, and that's green to blue shapes. If we divide both sides by 2, we can simplify this to 2 to 4. But that's not in its simplest form. If we actually divide by 4, we get from 4 to 8 to 1 to 2. And so this is the ratio that represents the green and blue shapes in its simplest form. And you might notice a link here with fractions in the fact that we can multiply and divide both sides to get equivalent ratios or to simplify a ratio. And then when we get down to 1 to 2, we can't simplify this any further. So now we have our simplified ratio, we could look at it in terms of the boxes that we started with when we were talking about the concentrate and the water. And you can see that all the parts are the same size. So in our original question, we had 4 parts in every single box, giving us 4 green shapes and 8 blue shapes. But we could use the same ratio to make different total amounts of pentagons. So instead of 4, we could have 5, and that would give us 5 green and 10 blue, but they would still be in the ratio 1 to 2. We could have 10 in every part, and that would mean that we'd have 30 shapes altogether. 10 would be green, 20 would be blue, but still in the ratio 1 to 2. Let's have a go at a couple of word problems that use the idea of ratio in a few different ways. And these are the most common problems that you might see, but they're all relatively easy to solve if we use the different parts and draw them out as bars and then try and work out what information we have and what information we need. So this question, there are 3 flowers for every 2 blue flowers. So that's our ratio. There are 15 flowers in the basket. How many blue flowers are there? So our ratio is 3 red flowers for every 2 blue flowers. So we can write this as 3 to 2. Now, if we draw the bars for this, we get 3 bars for red and 2 bars for blue. And the other piece of information that we have is that all of the bars together, so the whole basket, has 15 flowers in it. And they need to be sort of shared out into this 3 to 2 ratio. Now we have 5 bars overall in our ratio, and they're all the same size. And if they add up to 15, we can do 15 divided by 5. Each of them is going to be worth 3 flowers. So we can clearly see that there's going to be 6 blue flowers and 9 red flowers. Moving on to this next question, a jar is filled with sweets. For every 3 yellow sweets, there are 7 blue sweets. if there are 9 yellow sweets, how many sweets are in the whole jar? So we can see that our ratio is for every 3 yellow, we have 7 blue. So that's our ratio of sweets. And if we convert that into the bars, we have 3 to 7. It's also worth saying that that can't be simplified. If we had 3 to 6, we could then simplify that by halving it first. But 3 to 7, we can't simplify, so we're stuck with the 3 bars and the 7. And it's very important to label them with the correct sweet. We know that it is yellow sweets to blue sweets. If we get the sweets muddled up and do them the wrong way around, we're definitely going to get the wrong answer. So we have 3 yellow, and then we have 7 blue. The other piece of information that we have is that there are 9 yellow sweets. So our 3 parts for the yellow sweets is worth 9. That means each of those parts must be worth 3, and therefore all the other parts are worth 3 as well. There's 10 parts overall in this ratio. 3 times 10 is 30. And that's how many sweets would be in the whole jar. In a class of 24 children, there are 4 more girls than boys. What is the ratio of girls to boys in the class? So this one is slightly different, and it's similar to a few questions you might have had just with addition and subtraction, but it's also added in this ratio part to it. So let's have a look at it with the bars and see if we can make sense of these numbers. So it says that there's 4 more girls than boys, so we know that the girl bar is going to be longer than the boy one. And the difference, so there's 4 more girls, so that bit on the end is going to be worth 4. The other piece of information that we know is that the girls and boys together in the class make 24 children. So if we take away that 4 from the 24, we're left with 20. And these 2 remaining parts are both the same size, so each of them must be worth 10. 10 and 10 is 20, plus the 4 that's the 4 more girls gives us 24 in the class. Now we can work out our ratio. So we have 14 girls to 10 boys. The last step is, can this be simplified? Well, we could actually half the 14 and the 10, giving us 7 to 5, and that is the ratio in its simplest form. So we've come to our last question, and this one's slightly different because it's going to ask us to compare 2 ratios. So let's have a look and see how we can solve this problem. 2 glasses of orange squash are poured. The ratio of squash to water is shown in the diagram. Which glass has the stronger drink? So we can see from the diagram that A has a ratio of 2 parts squash to 3 parts water. And for B, we have 1 part squash or concentrate to 2 parts water. And we're being asked to compare these drinks because they don't have the same amount of liquid in total. It's challenging to compare them in terms of which is stronger. So all we have is the ratios. So how do we compare these 2 ratios? Well, the best way is if we make one of the parts the same size, we can then compare them. So we could make the squashes the same number of parts, or we can make the waters the same number of parts. And if we do that, we'll be able to find out which is stronger. The way that I would approach it would be, for glass B, if we double that ratio to 2 to 4, now both drinks have 2 parts squash. So drink A has 2 parts squash to 3 parts water, and drink B has 2 parts squash to 4 parts water. So we can compare the waters and see that drink A has got less water for the same amount of squash. Therefore, it must be the stronger drink. And this works for other questions where you're being asked to compare ratios. If you make one of the parts the same size by multiplying or dividing the ratios, then you can compare the 2 ratios easily.
So that's our look at ratios and 4 different types of questions that many students trip up on, and how you can use things like the bar model to help solve them. If you want more maths tips and looking at different topics, then check out the other videos on the channel.